In Algebra 2, when we spoke a lot about translations on functions, one of the translations we made, we did the vertical stretching and shrinking. Well, in the last section, that's what we did with changing the amplitude. There was also a horizontal stretch and shrink that we didn't talk a lot about in Algebra 2, but we did it here in the last section with changing the period of a sine and cosine graph. Some of the other translations we made on general functions was we moved functions up and down. So if you have a function like y equals f of x, if you add a number, that moves the graph up that many units. And if you subtracted a number from the original function, it would move the graph down that many units. For left and right, though, if it was inside the parentheses, this was a translation to the right, a units. And then if you added, it was a translation to the left. And it was the opposite of what we expected to happen, because everybody wants minus to be the negative x direction and positive to be the positive x direction. And we talked about how these were the opposite of what you thought they should be. So now let's add something to our sine and cosine function. The other sine and cosine functions we did were just a sine or cosine of k theta. Now we're going to add this plus c. C is going to do something called a phase shift, and a phase shift is just fancy terminology for a horizontal transformation, or in other words, moving the graph left and right. In order to determine how far left or right you're going to go, you're just going to take the part that's inside the parentheses, you're going to set it equal to 0, and you're going to solve for theta. So in order to solve for theta, the first thing I would do is subtract c, and then I would divide by k. Now, the phase shift is really going to be the absolute value of c over k. But the way this works is if you get negative c over k, so if c over k is negative, it's going to move the graph to the left. And if c over k is positive, it's going to move the graph to the right. Let's do an example of this. Now remember, when we graph, we're only going to graph one period of each of our functions. So I'm going to give you a little way to figure out where you're going to start and end your period when you move the graph left and right. So let's state the phase shift for each function and then graph the function. In order to find the phase shift, you're going to take what's inside the parentheses, set it equal to 0, and then solve for theta. The phase shift is pi, and it's going to be moved to the right because pi is positive. Oops, I don't want to write phase right, I want to write phase shift. And then I wanted to say that it's to the right. Okay, so here's how it's going to work. The interval that you're going to graph this on, you're going to graph it from the phase shift. And let me write this way. You're going to start at the phase shift, and then you're going to end at the phase shift plus the period. So this is important. Make sure you've written that down. So let's go back to this problem for a second. I want you to notice that the amplitude is 1. The period is 2 pi over k, but in this case, k is 1, so the period is 2 pi. So we're going to start our period at the phase shift of pi, and then we're going to end at the phase shift plus the period. So we're going to end at 3 pi. So when I go graph this, there's my coordinate plane. I'm just going to put pi here, and then I'm going to put 3 pi here. Those are my first and last tick mark. Remember, we're going to have 5 tick marks just like we did in the last section. So what's the tick mark in between? Well, it's going to be 2 pi. So this is 1.5 pi, which is 3 pi over 2. And this is 2.5 pi, which is 5 pi over 2. And the graph goes from 1 to -1. It's a cosine graph. And since it starts with a positive, it's going to start at its maximum. And so here are your 5 dots. And there's your graph. All right, let's do this again. Y is equal to sine 4 theta plus pi. So let's start with the easy stuff. The amplitude is 1. The period is 2 pi over k is 4. 2 pi over 4 reduces to pi over 2. The phase shift, we're going to set 4 theta plus pi equal to 0 and then solve for theta. So first I subtract pi and then I divide by 4. So I want you to notice that this is going to get moved to the left. Now I want to determine the interval on which I'm going to graph this. The interval is the phase shift to the phase shift plus the period. So we actually have to add negative pi over 4 plus pi over 2. If you're not sure how to add it, just have the calculator do the work for you. It's negative 1/4 plus 1/2, which is going to be positive 1/4. So that's going to be pi over 4. All right, now I'm ready to graph this. So if it's starting at negative pi over 4 and going to positive pi over 4, negative pi over 4 is going to be over here. And positive pi over 4 is going to be over here, and it's going to be equidistant from 0, which means that the middle tick mark is 0. That's the easy one. What I need to figure out are these. Well, let's do the tick mark that's between 0 and pi over 4. Well, it's half the distance from 0. So if you're not sure what that is, if you do 1/4 and then divide that by 2, hit math enter in your calculator, you're going to find out it's 1/8. So this is pi over 8. This is going to be negative pi over 8. It's a sine graph. So the sine graph starts its period on the x-axis, and then it goes maximum, x-axis, minimum, x-axis. And there's one period of that sine curve. Let's go back and look at one period of the sine graph again for a minute. So in all the graphs we've done so far, the graph has oscillated along the x-axis. That means it goes the same number of units above and below the x-axis. Well, that x-axis has a special name. It's called the midline. The midline basically is the line that goes through the middle of the graph. Well, that line can get moved up or down. So we could add a number to the graph, and they're going to use, I guess they use h, because h is the number that gets added or subtracted from the original function. Let's do that. Sorry, that should be cosine. That's the number that moves the graph up or down. So now let's talk about moving the graph up and down, because it's not gonna change the amplitude, but it's gonna change where the maximum and minimum are. So let's do a problem where we're going to move the midline. State the vertical shift in the equation of the midline for the function y equals 3 sine theta plus 2, and then graph the function. So the midline, how far the graph gets moved up or down, is this number here. It's a horizontal line, and all horizontal lines have the equation y equals. So in this case, it's y equals 2. So I'm going to start setting up the graph, and this is how I'm going to do it. I'm going to put a dashed line through 2. This is the line that the graph is going to oscillate about. All right, how far is it going to oscillate? Well, that's your amplitude. It's going to go 3 units above that. That's going to be its maximum. And then it's going to go 3 units below that, and that's going to be the minimum. So it's going to go down to -1, and it's going to go up to 5. Now I have to put the tick marks on my graph, so I need to know what the period is. The period is 2 pi over k, but in this case, k is 1, so the period is 2 pi. So remember, this is my x-axis, so 2 pi, 1 pi, pi over 2, 3 pi over 2. And it's a sine graph, so the sine graph starts on the midline, and then it goes to its maximum, and then it goes back to the midline, and then it goes to the minimum, and then it goes back to the midline. And there's your graph. Notice that I use different colors to do this. It might help you if you have a set of colored pencils in order to do this section. Now let's do a problem where everything gets changed. Your amplitude, your period, and it's going to have a vertical shift and a phase shift. Now there's going to be an order in which I'm going to recommend you do this problem, and we'll talk about that in a second. So it's a state the amplitude, period, phase shift, and vertical shift for y equals 2 cosine theta over 4 plus pi minus 1, and then graph the function. So here's the order in which I want you to do things. The first thing I want you to do is find the midline. The graph gets moved down 1. So the first thing I'm going to do is I'm going to draw a line here. And this is at -1. That is the line that the graph is going to oscillate about. How far is it going to oscillate? That's what the amplitude is going to tell you. It's going to go 2 units above, and it's going to go 2 units below the midline. Then the next thing I want you to find is the period and the phase shift. So we're going to find the period. The period's 2 pi over k. Well, what's k in this case? Remember, this is the same as 1/4 theta, so it's 2 pi divided by 1/4. If you're not sure what that is, one way is you multiply the numerator by the reciprocal of the denominator, so you do 2 pi times 4 over 1. Or, if you ignore pi, you can do 2 divided by 1/4 in your calculator, and you'll get 8 pi. Now I got to figure out what the phase shift is. The phase shift, you're going to take what's in the parentheses and set it equal to 0 and solve for x, or sorry, theta. So first you're going to subtract pi, and then you have to multiply by 4. So the interval on which we're going to graph this is always the phase shift until the phase shift plus the period. So we're going to graph this from -4 pi to -5 pi. I did that wrong. Let's try that again, because the period was 8 pi. Ha 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 ha. All right, the phase shift, so it's going to be the phase shift plus the period. Ha, there we go. So it's going to be from -4 pi to +4 pi. That looks better. So I'll call this -4 pi. So I'll call this +4 pi. That means the tick mark in the middle is 0. That means this one is at -2 pi, and this is at +2 pi. Now I'm ready to draw the graph. It was a cosine graph, and the cosine graph starts and ends its period at the maximum. In the middle, it hits its minimum, and then it's going to hit the midline at these 2 tick marks. And there's one period of your graph. Let's do another example. In a particular electric circuit at t seconds, the current is I of t is equal to 25 sine of 120 pi t minus 1 over 360. Draw the graph that models the current in the circuit. So, when you do these problems, the first thing you do is you look for a midline. There's no midline because there's no plus or minus a number here at the end, except for 0. That means the graph is going to oscillate about the x-axis because that's y equals 0. Okay, next. Then you're going to find the amplitude, and the amplitude is 25. So now when I go draw my graph, and again, just like we did before, cheap graph, call this 25, call this negative 25. Next, let's find the period. The period is 2 pi over k. In this case, k is 120 pi. Those pi's cancel, and you're left with 1 over 60. And then the phase shift. To find the phase shift, you take what's inside the parentheses, and you solve for the variable. And since the variable is t, that's what we're going to solve for. So t is going to be positive 1 over 360. Sorry, that's a 0. So when I draw my 1 period, where's my starting and ending? My interval is going to start at the phase shift, and it's going to end at the phase shift plus the period. If you add these in your calculator, you're going to get 7 over 360. So we're going to start at 1 over 360. We're going to end at 7 over 360. In order to find out what the tick mark halfway in between is, the tick mark in between is the average of these two numbers. So if you add them and then divide by 2, you may have to hit math enter, enter. You'll find out where it's at. And it's going to be 1 over 90. The tick mark between 1 over 360 and 1 over 90 is the average of those two. So you can add those two fractions and then divide by 2. Don't forget to hit math enter, enter. And you're going to find out it's at 1 over 144. And then this last tick mark is the average of 1 over 90 and 7 over 360. And that's going to be 11 over 720. Now I'm ready to graph it. It's a sine function, so the sine function starts and ends on the midline, and in the middle it's on the midline. In between those two it hits its maximum, in between those two it hits its minimum, and that's 1 period of the graph. What if I want to go the other direction and I give you all the important information, but I want you to write the equation? We did this in the last section where I would give you the amplitude and period, and then you had to do a little math to find k in order to plug into the equation. So we want to write a function of a cosine, so it's going to be y equals a cosine of k theta plus c plus b, where the amplitude is 5, the period is 2 pi, the phase shift is negative pi over 2, or sorry, negative pi over 8, and the vertical shift is negative 2. Now, since we don't know what the graph looks like, just like in the last section, we're going to call this plus or minus 5, because I don't know if that cosine function starts at its maximum or minimum. The other easy thing to plug in without having to do any math is the vertical shift. It's negative 2. So I'm just going to take that out, and now I have replaced 2 of the 4 variables. So the next thing that we're going to do is we're going to try to find k. So the period is going to equal 2 pi over k. Remember, that's a proportion, so I get 2 pi k is equal to 2 pi. And then in order to get k by itself, we have to divide both sides by 2 pi, and I find out that k is 1. So if k is 1, do I have to write a number there? No, you don't. Or you can put a 1 there if it makes you feel better. Now the fun part is dealing with the phase shift. I'm going to tell you that since the phase shift is equal to negative pi over 8, I need negative c over k, which is what we found out a couple of problems ago that we get when we're finding the phase shift. And we're going to set that equal to negative pi over 8. And the reason you have to find k first is because I know what k is now. I know k is 1. So the only thing I don't know is c. Look, it's another proportion. Let's solve this for c. So negative 8c is going to equal negative pi. The negatives are going to cancel, and when I divide, I get pi over 8. So I'm going to replace c with pi over 8. And there's my equation. So again, first you're going to plug in the amplitude and the vertical shift. Then you're going to set the period equal to 2 pi over k and solve for k. And then you're going to set the phase shift equal to negative c over k. You found k in the previous part of the problem, so you'll replace that, and you'll be left with one variable left to find, and that'll be c, the phase shift. We're just going to very briefly look at this last one because this is not something we're going to test you on. However, the concept behind it is important to understand. It says graph y equals cosine 2x with sine x. This is called a compound function because it's adding two functions together. Now the way it works is it literally adds the outputs of each of the functions. So what I did was I made a little chart here of some input values from 0 to 2 pi. And then I found the cosine of 2 times each of those values, and I want you to notice what they do. 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. And then I did the sine of each of those values. Well, what happens then when I find the sum of each of those? So if I were to go graph this, then I would graph, 0, 1, and then I would graph pi over 4.707, and then pi over 2, negative 1, and then I would graph 3 pi over 4 at 0.707, and then I would graph 1 pi at 1, and so the graph would start to look something like this. If you want to look at the graph on the calculator, as long as you're in radian mode, so be in radian mode, go put the equation into y1 equals, and then go to zoom trig under the zoom function. I think it's number 7. And this is the graph you'd see. And that would be the graph of the sum of those two functions. And that is translations of sine and cosine functions.